In Python, conditional statements allow a program to make decisions based on certain conditions. Think of it as a way to tell the program, if this happens, do this, otherwise, do something else. The three main conditional statements in Python are if, elif, and else. The if statement checks whether a condition is true, and if it is, the block of code inside it runs. If the condition is false, the program moves on. The elif, short for else if, statement helps check multiple conditions one after another, ensuring that only one block executes. Finally, the else statement is used when none of the conditions are met, providing a default action. These statements are crucial in programming because they allow us to control how our code behaves in different situations. For example, if you're writing a grading system, you might use if to check for an A grade, elif for a B grade, and else for all other cases. Understanding conditional statements will help you write smarter, more dynamic programs. In Python, conditional statements are essential for making decisions in a program. They allow us to execute specific blocks of code only when certain conditions are met. One of the most commonly used conditions is checking whether a number is greater than or equal to a certain value. For example, consider the case where we need to determine if a person is eligible to vote. In many countries, the legal voting age is 18 years or older. We can implement this rule in Python using an if statement. The program first assigns the value 18 to the variable age. The if statement checks the condition age greater than equal to 18. Since the condition is true, the print, "you are eligible to vote," statement is executed. If the value of age were less than 18, nothing would be printed. In Python, conditional statements allow us to make decisions based on specific conditions. One of the most common scenarios is checking if a person is eligible to drive. In a driving eligibility check, we can use the AND operator to ensure that both conditions, age and possession of a valid driving license, are met. The condition age greater than equal to 18 and has underscore license ensures that both values must be true for the person to be allowed to drive. If the individual is 18 years or older and has a valid driving license, they are permitted to drive. However, if either of these conditions fails, meaning the person is either underage or does not have a license, the program will display, "You are not allowed to drive." This approach ensures that only qualified individuals can operate vehicles. The AND operator is crucial here because it requires both conditions to be true for the overall statement to be true. This logic is widely used in government transport systems to regulate driving eligibility, ensuring road safety by permitting only those who meet legal driving requirements. Additionally, this concept extends beyond driving rules and is implemented in various security and access control systems, such as verifying age restrictions for online services or allowing entry into restricted areas based on multiple criteria. In many real-world applications, we often use nested conditional statements to evaluate multiple conditions in a hierarchical manner. For example, imagine we are checking if someone is eligible to enter a restricted area, such as a nightclub or an event. The outer if condition first checks whether the individual's age is greater than or equal to 18. If this condition is true, the program proceeds to evaluate the next condition inside the nested if. Here, it checks if the individual has a valid ID by using the has_ID variable. If the person has the required ID, access is granted. However, if the has_ID condition is false, the program will output that an ID is required for entry. This nested structure allows for more complex decision-making, where each level depends on the outcome of the previous condition. For example, in a secure building access system, the outer if might verify if the individual has the appropriate security clearance, and the inner if could verify if the individual is using an authorized security badge. Such multi-level checks are critical for ensuring safety and security in high-stakes environments, like government buildings, secure facilities, and online systems where access is restricted based on multiple factors. The flexibility of nested conditions makes it possible to handle various scenarios based on several factors, ensuring that decisions are made with precision and accuracy.